Okay, so OpenAI just dropped GPT-3.5 Codex-Spark, which is their first model running on custom purpose-built hardware. And this thing is extremely fast. We are talking about 1,000 tokens per second, which is kind of crazy for a frontier lab model. We haven't seen anything like this before. Now, this is possible thanks to the purpose-built hardware by Cerebras. OpenAI partnered with Cerebras on using their custom purpose-built hardware for large language models. Now, this is critical because for most coding applications, you want to be able to use a very fast model that can generate code extremely fast. And that's why OpenAI is presenting this as an ultra-fast model for real-time coding in Codex. Now, this is a smaller version of GPT-5.3 Codex, so you definitely are going to feel some loss in performance. However, you don't need the frontier model for every task. Now, talking about frontier, Google just also dropped Gemini 3 DeepThink, which is their best model for tasks that need extreme level of reasoning and thinking. There's also a MiniMax M2.5, which is a stronger, faster, and smarter open weight model. And then we have GLM-5, which is going from vibe coding to agentic engineering. It's again an open weight model. Now, we're going to talk about all of them, but first let's focus on Codex-Spark. This is designed for real-time coding, and according to OpenAI, it can deliver up to 1,000 tokens per second. Now, there is a very interesting trend that is happening in the AI space. All of these frontier labs used to talk about AGI, or general purpose system, but if you look at the recent trend, everybody is specifically focusing on coding. And the reason is that if you can get coding right, you can pretty much do any task that has verifiable reward. Also, coding is going to enable agentic uses, so these models actually become economically viable for knowledge work if they are good at agentic tasks powered by a coding model. So a few quick notes. This is going to be only available to ChatGPT Pro users, and this is specifically designed for working with Codex in real time, and you'll be able to power sub-agents using this model. Now, this comes with a much smaller context window of 128,000 tokens compared to the normal 200,000 tokens context window of GPT-5.3 Codex. And more importantly, this is specifically designed for speed, so don't expect the same level of intelligence as the vanilla GPT-3.5 Codex. It suffers a little bit when it comes to performance. Now, here are a few examples. So we have GPT-3.5 Codex on the left side. We have GPT-3.5 Codex-Spark on the right. And GPT Codex models are notoriously famous for their low speed. However, if you look at the Spark model, it's actually already built the app and it's already testing it, while GPT Codex is still in the planning and file creation phase. Here's another example. In this case, it's planning or writing a plan for app. So it's already done. Now, you don't need the latest and the greatest state-of-the-art model for every task. These models get very expensive very quickly, especially if you're looking at a sub-agent architecture. You want a compromise between speed and intelligence, right? So models like GPT-3.5 Codex-Spark are going to be very critical if you are building systems with sub-agents that can have very well-defined tasks assigned to those sub-agents. So you want to use a model like this when speed is important to you. So here's a quick example of the type of performance you could expect. There's definitely a performance drop compared to the vanilla GPT-3.5 Codex, but it's going to take a much shorter time to complete tasks for you. You also see similar pattern in Terminal Bench. Now, I think we should think of this more of as an experiment of and a preview, because with their new responses API, they saw 80% reduction in round trip time and time to first token by 50% with their persistent WebSocket connection. Now, all of this is powered by the Cerebrus Wafer Scale Engine 3. It also shows you the viability of these custom purpose-built hardware for inference. This is where NVIDIA is going to have a lot of competition. They recently acquired Grok, so I think they are also moving in the same direction, which shows the viability of this purpose-built custom hardware business. With this release, OpenAI is really targeting two different sectors. One is long horizon reasoning and execution, and then real-time collaboration for rapid iteration. So models like Codex-Spark are going to be very critical if you want real-time collaboration. And then you're going to have these much bigger, more capable reasoning models that are going to act as orchestrators. As I said, it's only available to pro users at the moment because of the hardware limitations. I don't think the Cerebrus team is able to provide enough hardware wafer units to OpenAI at the moment. But you are going to get different rate limits for this compared to the normal OpenAI API. Okay, now let's talk about Gemini 3 Deep Think. So this is a specific version of the Deep Think architecture that is trained for Gemini 3. And for reasoning tasks, it blows everything out of the water. Specifically, if you look at RKGI2, it's the first model that crossed 80% on something that was supposed to be a very hard challenge for large language models. Also, on coding tasks, it does show a very significant improvement compared to something like Opus 4.6. But keep in mind, this is not your daily driver. And it's actually interesting to see the contrast between the two models. So DGX-Spark or Codex-Spark by OpenAI is specifically designed for speed. On the other hand, we have Gemini 3 Deep Think released on the same day that is designed or trained for very compute intensive reasoning tasks that can take a long time. So the user is not really interested in instant responses, but they want the accuracy of responses. So it's more of a research grade model. I was part of their early access program. It's a pretty incredible model for hard tasks. So I'll highly recommend to check it out if you are on the Ultra subscription. Now, in the last couple of days, we also had two major open weight releases. Today, we had one from MiniMax M2.5, which is now state-of-the-art open weight model, at least on these benchmarks, when it comes to agentic coding. And it just surpassed the GLM-5 from Z.ai, which was released yesterday. So it's moving extremely fast. Now, from my quick experiments, both of these open weight models are very capable models. However, I would say they are not really stable. You don't really get consistent results. As always, like, don't just go on the benchmarks. You actually want to do experiments yourself. Now, that being said, I really want to go back to my original point that you don't need the latest and greatest model for every task. You could actually use something like the MiniMax M2.5 or a GLM-5 as a sub-agent, as a potential replacement to even Codex-Spark models. Because the performance to cost ratio that you get with some of these open weight models, especially M2.5, is pretty incredible, and it's really, really hard to beat. And it becomes more important in knowledge work where the cost is a big factor. For businesses beyond coding, it's not just trying to run the latest model, they have to care about how much it costs. And that's why you probably have seen this term workhorse model. And the idea is that you want a model which is intelligent enough to perform your actions very fast and at a reasonable price. And that's why you see that the Frontier Labs offers not only the models at the frontier, but also workhorse models like Haikus of the Worlds, the Flash of the Worlds, and now the Codex Minis and Codex-Sparks. Anyways, this is going to be a very interesting year. We are just in the second month and have already seen some incredible releases. So really excited about what's to come. Anyways, I hope you found this video useful. Thanks for watching. And as always, see you in the next one.